for the very first volume of the new Thinking Aloud dialogue series, Is There Life After Death? Publication date is June 1st.
Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. Today we'll be talking about infinity and non-locality. With me is Dr. Vernon Neppe, who is the director of the Pacific Neuropsychiatric Institute. He is also the author of a book called Reality Begins with Consciousness, which he wrote with Dr. Edward Close, a physicist. And he is the author of over 700 scientific papers. Welcome again, Vernon.
Thank you so much, Jeff.
It's a pleasure to be with you once again and to talk about infinity, one of my favorite topics, actually.
Yeah, a very, very difficult and challenging topic.
Well, it's given mathematicians a lot of conundrums, actually. Infinity, it seems in a way simple, like the infinite, why that's just as far as you can go in every direction, but mathematicians have struggled over it.
Indeed. Difficult area and difficult to quantitate mathematically. And there would be some of those who would say you cannot quantitate it and you cannot subdivide it. So before we begin, we're dealing with differences in terms of definitions and perspectives.
And you have both the infinitely large, the infinitely small.
Yeah, the infinitesimal in that context, and that's another side of it. And something that's worthwhile just mentioning, maybe at the start, because you've mentioned that infinitesimal, because the whole basis of Newtonian Leibnizian calculus, two very, very great mathematicians in that context, is the so-called infinitesimal calculus, which means that you keep getting smaller and smaller and smaller and smaller until you approximate almost to zero in terms of infinitesimals.
Yeah, might as well be zero.
Yeah. The problem is the problem of quantization.
Yes.
You'll remember the great German Nobel laureate physicist Max Planck, effectively the man who gave Einstein his chance. And he recognized the quantization of energy. In other words, that they were little packets.
Yeah. In other words, we're talking now about physical reality, particles. And so
yeah, exactly that, and even smaller. How small can one get? And the smallest one can get is maybe to the quantum. Now, this has some implication from the point of view of infinitesimal calculus, because when one deals with our macro world, this is fine, but one's not even going that direction, one's not getting so small. But when you get really small in terms of the quantization, the quantum, it suddenly creates a limit in terms of how far down you can go.
A limit for physicists, but not for mathematicians.
Well, it should not be a limit not for mathematicians, because it should be.
You think
because
so?
When you start doing calculations in quantum physics, and maybe when you do these massive cosmological calculations where you're busy launching a rocket to the moon and you want to be absolutely precise, it might be that if you're an inch out over millions of miles, or we might even be talking much larger components, that might be highly relevant, because the relevant part about it, and one can show this mathematically, and in fact Dr. Edward Close and I have shown mathematically that there has to be, therefore, a different kind of calculus. And this is, I've had the privilege to work with Edward Close, who initiated the calculus of distinctions.
Yes.
And when we work with dimensions, it's the calculus of dimensional distinctions. And this is far more precise for these quantized, finite, little discrete pieces than Newtonian Leibnizian calculus.
And now, so what you're saying is that the idea of infinitesimals,
Right.
Where you just keep getting smaller and smaller and smaller until you approach zero. So it might as well be zero, but it's not zero. You're saying there's a bottom limit here. Once you reach the Planck length, or the length of the quantum in physics, there's no point trying to go any smaller.
Yeah, and that creates a whole new body of mathematics. And what we've been involved with the calculus of dimensional distinctions doing is creating all sorts of ways of formulating real natural calculations. So, for example, Quant had a whole string of different constants, but they were not natural constants. They were convenient. What we've done is we try and normalize to natural figures, for example, the electron is 1. And when you start calculating out these things, suddenly calculations become much, much easier. So that's the one end, but it introduces the other end because there are two major components in terms of that introduction. The infinitesimals we've seen are quantized, have limits, but they are discrete. It's like watching a TV. We cannot differentiate what is special about that TV, but in fact they have all sorts of dots and smaller dots and smaller dots, but our eye cannot pick up on that. They are discrete and pixelated.
But my understanding is this, that even though these quanta, these tiniest of all particles are discrete, and it may seem like the universe is so big, there are infinitely many of them. They're not. That some scientists believe they can calculate the number of subatomic particles in the entire universe, that it's a finite number.
Yeah. Well, this is what we're differentiating here at the moment, because I said effectively there are two kinds of infinity, and we began with the concept of infinitesimals, but began with the concept of actual quantization and limits and little spots, little dots, little components there. That is the finite, discrete nature of our universe. And in that way, you could potentially calculate things, except you'd have a real job. And the real job is Edward Close and I have demonstrated that there is a 9-dimensional quantized finite reality that we exist in, as opposed to we experience. We only experience length, breadth, height in 3 dimensions and a moment in time.
Through our normal senses.
Through our normal senses, 3S1T.
Yes.
So I'm differentiating before we begin experience from 9-dimensional existence.
Because,
however,
I mean, in our consciousness, in our dream life, for example, people experience what might appear to be realities way beyond 3D.
Some people might, yes. And one doesn't know because you can't visualize it, you can't hear it, you can't touch it, you can't feel it.
But you have dreams yourself, I'm sure.
I do have dreams and higher aspirations of dreams. However, the point about it is, what am I dreaming it in? I am generally dreaming in the physical reality I experience, 3S1T.
Okay.
But the point that I'm making, and we can come back to all of these, and we will, is the fact that above those 9 dimensions is what we call the transfinite. And this was an area that particularly interested a mathematician named George Cantor.
One of the great mathematicians of all time.
Yeah. Who won the Sylvester Prize and tried to publish an article in the 1880s and was told by the editor of the Mathematical Journal, we're not ready for it, please resubmit in 100 years, which pushed him into a depression. But he was very, very much into this whole component of the infinite. Mm-hmm. Now, this is the discrete infinite, the quantized infinite, if you want, and we call that the transfinite. Mm-hmm. And there must be an area of correspondence of this transfinite infinite with the continuous infinity. Mm-hmm. And this is what we usually refer to as infinity. So I'm differentiating discrete components from continuous components. And this difference is enormous and very, very exciting.
My understanding is that George Cantor came up with many, many different levels of infinity. We might think that there's just one kind of infinity, but he described any number of different infinities.
Yeah, he described, so to say, the infinity of infinities.
Yes.
Now, it was bad enough for a mathematician or a scientist in the 19th century, going into the early part of the 20th century, to dare to talk about infinity. Mm-hmm. This was a taboo.
Isn't that interesting?
When you start talking about the infinity of infinities, this impacted upon the whole component of religion.
Yeah.
It was felt that he was insulting God by so doing. Mm-hmm. And he was very much rejected because of that component. So indeed, he described the infinity of infinities. But when you go along and you look this up on the internet, for example, you'll find very little there. Mm-hmm. You'll find most mathematicians, most physicists, if they even dare to talk about infinity, they will talk about it as one block.
Uh-huh. Well, I know in some of our earlier discussions, and even now, you've referred to 9 dimensions, and I'm aware of a concept called Hilbert space, which is infinitely many dimensions of space.
Yes, indeed. Hilbert space is very, very different. But again, you've got to look at things in another kind of context as well. Mm-hmm. You've got to look at things in the context of space, time, consciousness. Mm-hmm. And this is how we're perceiving the 9 dimensions. But what is interesting in that regard is that point of separation between our physical reality and our higher reality, between what I'm calling our experience, which of course is restricted 3S1T, restricted space-time components, because the time is just one point in time, the present, and the space is a length, breadth, height, but a length, breadth, and height in our physical reality. Yeah. When you jump, one of the phenomena that we've described, where some people are referring to this as non-locality, is we've described a certain immediacy. Mm-hmm. And that immediacy is extremely important. You see, if you're talking about space and time and you're going up dimensions, and there's no real difference except that these different dimensions are measurable, it's almost a so what point. But this is not a so what point, because that immediacy shifts the whole fabric of space-time. Something can become immediate. Mm-hmm. So one of the factors that might be linked up, and of course there's going to be those people who say, no, we can describe this all in 3S1T. One doesn't need anything else. Yeah. And the fastest one can get is light speed. And you cannot, if you're below light speed, you cannot exceed light speed. And we all know this. And everything is, they'll even use terms like relativistic. And suddenly I'm saying there's immediacy.
Now, when you use the term immediacy, I gather you're referring to what some people would call quantum entanglement.
Yeah, I was about to actually give entanglement as an example of immediacy, because people can understand it, and it's well demonstrated if one looks at the numerous different physicists that have been involved with studies of entanglement. And amazing. But the point about it is, here you're not even saying, well, this thing, the message, let's use that term message, is traveling from point A to point B at the speed of light. It's going beyond the speed of light.
In other words, a particle at one end of the universe and a particle at the other end of the universe, separated by billions of light years, could be correlated so that a change in one is instantly reflected in the other.
Yeah, it's an instantaneity. And there have been various bits of research in this regard getting to larger and larger distances.
This is what Einstein referred to as spooky action at a distance.
Yeah, so we had our spooky action at a distance, and what to me is puzzling is one can spend billions upon billions of dollars on space travel. And suddenly you say, hold on, let's just jump dimensions. Let's get to those instantaneous dimensions. We can save billions of dollars, and maybe we can, in some kind of way, project ourselves or project our thought or project maybe our instrument. We were talking about conscious robots at an earlier stage. We project it, and boom, we can go off billions of light years in a fraction of a second. Could it be that one's going through boom, 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 certain points, and one is traveling from here to there, even though it's billions of miles, in that instantaneous moment, by going right across, boom, hitting the right kind of vortices in this way. You can build up a wonderful model this way, and this is part of what we've been doing.
And this is what you're referring to as non-locality.
Well, it's not what I'm referring to as non-locality.
But other people do.
Larry Dossey developed the term non-locality, a good term, and sometimes people use this term because they want to avoid another term which has become prejudicial. You know, in the history of the different mechanisms, the term psi, to me, is still quite acceptable, PSI. But for some, wow, we better start
you're talking
using
about psi as used by parapsychologists.
Exactly, yeah.
And they're referring to psychic functioning.
Exactly. So consequently, we better not use this term psi. Let's use this word non-locality. Now, of course, the physicists were getting rather upset because they were using it in a different fabric.
They also use the term psi, as a matter of fact, referring to the Schrödinger probability waves.
Yeah, and this is why, you know, when we were talking earlier, we used the word Gimmel, which at least is a different language, and we really can lay claim to a massless, energyless third substance called Gimmel, or third component called Gimmel. We don't need to worry. But psi is a little bit of a problem. Non-locality is a big problem for physicists. But here, effectively, there is still the implications of space-time. And let me just move here, because I think that this is highly pertinent. And you use those implications in all sorts of ways. So even beforehand, people would talk about vibrations. And when you talk about vibrations, you talk about harmonics, and you're talking about a distance over a period of time. And that might be the vibrational frequency. Well, the first thing that we've done is we've said, hold on. Let's change this. We know that mass, energy, consciousness are all linked up. They are in union. They cannot be separated. Or if you want, more specifically, based on some of these other YouTubes that I've done, mass energy Gimmel, and Gimmel, we think, in part his consciousness, is all in union.
You use the word tethered.
They are tethered together. They're in union together. I like the term union, which came actually from Hermann Minkowski in 1908, when he spoke about henceforth time and space are in union. Well, here I'm using in union, including consciousness.
Well, Minkowski was also, I believe, responsible for the way physicists use the term non-locality, because he developed the notion of the light cone.
Yeah.
In other words, whatever is reachable by photons would be inside the light cone, but if it's faster than a photon, then it's outside the light cone and therefore non-local.
And this whole component of photons we could introduce when we get to this continuous infinity.
Yes.
But here we are. So we have our non-locality, a term I don't like. And the reason why I don't like the term is because everything is relative. You see, people say, well, we don't need to worry. We've got our whole special and general theories of relativity. But these are also relative to the physics that we know in our 3S1T physical universe.
Yes.
If you are going beyond to 6 dimensions, 9 dimensions, suddenly there are fundamental changes. So, for example, time changes. Space extends well beyond this just physical reality. And, of course, we ignore it because we don't recognize its existence. Consciousness is existing. So suddenly I have a whole new model, or we have, of 9 dimensions, and you might say, well, you know, very nice, this guy's talking about 9 dimensions, but it could have been 8, or it could be 7, it could be 12. Well, first of all, we've spoken about things being volumetric. So if you're talking about anything in terms of dimensions, you ought to be talking 3, 6, 9, maybe 12, 15. It has to be in threes. It's not a jump up from 3S1T to a 5th dimension as Kaluza and Klein perceived it. If they were doing this, they missed out because of consciousness, but they also missed out because of the volumetric component. But in any event, when you start jumping these ways, you don't take into account that consciousness, almost all of it, because it's part of that existence, but it's not part of the experience. And that consciousness is at that higher level. And you spoke about the jump in terms of photons and saying, well, you cannot go beyond the speed of light. Well, here we're talking relativistically, and we've got to use 2 important phrases when we talk about infinity and relative non-locality. And the 2 important phrases are relative to the dimensional domains we're talking about. And our dimensional domain is relative to restricted 3S1T. We can't see the X-rays or the infrared or the ultraviolet, so it's restricted. We cannot hear what some animals are hearing. We don't have the sense of olfaction maybe of dogs, but let's just say the dimensional domain we live in is 3S1T. Now, when we go beyond that, it might be that we can suddenly figure out all sorts of things. We can suddenly figure out that maybe we don't need to live in a dualistic universe of this is our physical reality, and we also have a mind of some kind. Some people would say a soul or whatever. And that is in a different reality. And how do the 2 communicate? And there's this whole debate in terms of René Descartes and Cartesian dualism and extensions.
So you're saying that these dilemmas that seem insoluble to us from the standpoint of conventional reality are resolvable from higher dimensions.
Of course. And when you can demonstrate mathematically and prove that you're dealing with 9 dimensions specifically, that's very nice.
But don't you say that the 9 dimensions are also embedded in an infinite space?
That's the whole component. So the first 3 space might be embedded in the next 3 time, but it's a dynamic embedding, and the next 3 are embedded in consciousness. And you can mathematically represent these, incidentally, in a different kind of way, which is interesting. Now, that word embedded says it's contained in the infinite. Now, what does it mean? It means that we over here in our physical 3s1t reality, still, our whole reality is not only those 9 dimensions, quantized finite, but also a component of the infinite where we are embedded and interacting. And this is terribly important. It's not a case of we pray and we pray and we pray and we get to this high level and eventually we attain a certain kind of nirvana, a certain kind of reality in the infinite. At every moment in time, just as we're in union with space, time, and consciousness, just as we're in union with mass, energy, and consciousness content, that component is in union, is embedded within the infinite. It's not a dualistic perception. It's the same perception. It's just an extension that we cannot conceptualize unless we were relative to that. In other words, in the infinite. And we therefore are talking about those 2 phrases, relative to and from the framework of. So let's imagine that we die. We have physical death.
Yes.
We don't know what happens, but it could be that we're in a different dimensional domain experience. We're the same individual. It might be, and we'll talk about this because this is a little bit complex, very interesting, but it might be that as the same individual, we still are experiencing just different parts of that 9-dimensional reality. We're in a different dimensional domain.
Well,
so from that framework, we're experiencing our reality differently. But in that context, in one sense, and this is complicated, we are an individual experiencing that. We're experiencing it in finite reality as well as the infinite reality.
Well, that's what I was suggesting earlier with regard to dreams. I'm not sure that dying and going through what the Tibetans would call the Bardo planes is necessarily much different than entering into a dream reality.
It might not be. And I sometimes have used this actual parallel and saying, well, you know, we have different altered states of consciousness, term Charlie Tart introduced. And in that regard, we have, I think I've described something like a dozen different altered states of consciousness. And of course, the dream reality is one of those altered states.
Well, it would be great if we could map these out mathematically. And I think when you're talking specifically about the 9-dimensional and the rotations and vortices associated with a 9-dimensional reality, it gives us the potential for actually mapping it out.
Exactly that, and it might be that some people who, so to say, are deceased experience different dimensional domains to others. And therefore their experience would be different. They obviously are differentiating the immediacy, and they are also linked with the infinity, but this is where, to me, the infinity of infinities comes, because the only aspect that could probably experience all of that infinity of infinities would be a deity, would be God.
Yes.
And at that point in time, one would be talking about time, which is from the beginning to the end, except there's no beginning and no end in that infinity. It extends eternally, so to say. We're talking about space, which has extent, except in another way there is no extent because it extends forever. It extends forever in the spatial sense.
Which is a little bit different than present-day cosmology that talks about curvatures in space so that they say the universe is so many billion light years across, and then that's that.
No, it's not different.
Because it curves in on itself.
No, it's not different. We're talking two different components. We're talking about the infinite that extends forever in space.
Yes.
It extends eternally in time.
Right.
And a consciousness reservoir that is without end. This is very different from the finite universe, where indeed there might be the horizons and the bending in turn. We know from general relativity that indeed there is. But we're talking two different components.
Well, it's one reason I think why physicists talk about multiverses, that beyond our known universe with its finite dimensionality, there could be infinitely many others.
Well, I'm not sure if there could be infinitely many others. Let me just say this, that if we had a multitude of different universes, and maybe we do, but those universes would still obey the same fundamental laws of physics. The quark, the up quark and the down quark would be the same. The neutron would still be made of two down quarks plus one up quark in a triad. The proton would still be two up quarks plus a down quark. The electron would be another elementary particle. The photon would still exist. In other words, if we're talking about this, we're talking about a replication of our universes, and it might be a very, very, very large number, but it's not an infinite number because they will still have to obey the same fundamental laws of physics, except those laws of physics are not the laws of physics that we think. They extend across.
Well, some of the physical constants might be different. You talked earlier about the Cabibbo angle. Perhaps the Cabibbo angle or the fine structure constant would be different in a different universe.
Why?
Well, certainly there are physicists who speculate on exactly that.
Well, you see, the point about it is you've got to look at fundamental particles at that finite level, and however many universes or multiverses one's talking about, you're talking about the same particles.
Well,
now, if these
it's all culturally dependent. The whole notion of up quarks and down quarks is just a few decades old. In another 100 years, we may conceive of it entirely differently.
We might. But then our multiverses would be conceived of entirely differently based on this same replica. There are a limited number of replicas. Whatever the rules are, they might be different, but they should be the same for all of these different multiverses.
Well, how does that fit into the world of infinite possibilities?
Okay. This is how I think it fits in. And we will later on be discussing free will. Imagine a tree with roots, and it might be that those roots are highly pertinent at that infinite level, but leave that out. This is just one philosophical component. But you have your branches and your infinite possibilities. You maybe are making choices along those branches which lead to other branches. And in that context, instead of saying, well, we're talking multiverses, we're talking different kinds of branches. And as you branch out, you're leading to a different kind of reality, which others are not experiencing because they were experiencing different branches. And this is all within that whole sort of mythical or metaphorical forest. And the metaphorical forest is all of existence, except in the infinite. That metaphorical forest never ends.
That's a beautiful image.
And this is how I'm seeing it. Thank you for that sort of compliment there. But this is how I'm seeing these different components. Let me just translate this to psi phenomena.
Okay.
Because as I'm seeing it, contemporary psychical research or parapsychological research, or if you want, I prefer to use the word consciousness research just because these terms have become somewhat prejudicial, will talk about what is happening now, and that's contemporaneous, what is happening in the future, and that could be precognitive, and what is happening in the past, and we can talk about retrocognitive. Yes. So this is our component of time.
Right.
The problem is we're dealing with, effectively, the way we're describing it, a linear time. Past, present, future. That's just linear.
Mm-hmm.
As I've conceived of it, it has to be multidimensional, and there is some data suggesting multidimensional, or if you want, three-dimensional time.
Isn't that fascinating?
Yeah.
It's hard to conceive of, but how would the other dimensions work?
Well, let's then go to space, because, people think, well, it's easy. You've got your three finite integral dimensions of space, yes, all in numbers, and they are all intervals in terms of time.
So we could move horizontally in time as well as vertically.
Exactly that. And we could do, in a way, the same in terms of space, except we're extending well beyond that physical reality. Yeah. We're going much, much higher. Because people say to me, well, consciousness is different, because how do you measure consciousness? And I say to them, you can measure it by ordinals. In other words, good, better, best, or mild, moderate, severe, profound. But we don't know the distances there. And they say, well, that's very different. Well, you can measure time exactly. You can measure space exactly. And I say, you can't. You can only measure it exactly in this 3S1T, physicalistic universe. Once you've gone beyond that to what they were calling the non-local, which I might call the relative non-local, except incidentally, I prefer to use the term relative dimensional, or maybe different distinctions, relative distinctions. But once you've gone beyond that, time and space are no longer interval. They are now ordinal. And they go up and up. Yeah. And in fact, because time is embedded in consciousness, and space is maybe embedded in time, this is where the term going vertically, going up there, we are dealing with a whole new fabric of thinking. So suddenly when we talk about psi phenomena, we could be talking about things that are happening at the fifth, sixth, seventh dimensions, say. We could be talking about things that are happening in another dynamic dimensional fabric where in a different directional, different plane, a different forest, if you want, you are at the sixth dimension and the eighth dimension and the ninth dimension.
It's very hard for the average person, I think, to visualize all of this.
Very difficult. And sometimes it's easier to visualize it in things like a Rubik's Cube. And in fact, my colleague, Dr. Edward Close, is writing a book at the moment on the Rubik's Cube, because you can visualize these things almost differently. And here we're talking about polyhedron kinds of phenomena as opposed to spherical phenomena as well. Yeah. You see, the key about it is this, and this is the whole bottom line, if I had to describe this in one sentence. We have Dr. Kurt Gödel,
yes,
great German mathematician
and logician,
who, from that point of view, spoke about a theorem. And he said that nothing can ever be complete because, so to say, you're inside the box. And how can you get the whole perspective of that box from the inside?
No system of logic or thought is capable of describing itself.
Exactly. So you've got to go outside the box. Yeah. Now, if you have finite reality, that's a big, big box. Let's make it a 9-dimensional finite reality. Let's even add in the transfinite. And this is how, using the logic, one extends to the continuous infinity. So we have the discrete finite, We have the discrete transfinite, and you have a continuous infinity that to me is an infinity of infinities, and that finite is embedded in the infinite, and therefore there is communication that is occurring all the time. But it doesn't mean to say that once you've hit the infinite, you've hit all of the infinite. You've just maybe hit certain points in terms of that infinite. And this is why there's an infinity of infinity. And this is why we can communicate all the way through. And this is why, if we are talking about order, you see, to me, I don't know about you, Jeff, but I do think I know about you, and I know about me. We are individuals with order. Our whole human population, everything that is living, has order.
Yes.
And yet we keep hearing from these physicists, entropy, we tend to disorder.
Yeah.
This is the natural state. We know about the laws of thermodynamics. You can't argue this. And you say to yourself, hold on. Yes, you can argue it, because if there is an order, that order has to come from the infinite reality as a consequence. And this is where we use the term Ordropy. Initially, we used the term negentropy, which people have used.
Yeah.
But that negentropy implies one-dimensional kinds of disorder. Ours is an order that exists in a kind of reality. And you extend this, and there's something rather remarkable. It's this thing that people talk about called physical death. You physically die. Well, if you die, it's a nothing. We know you've got negentropy or entropy, and that's it. Using this model, we are an essence, a nine-dimensional essence, if you want, but a nine-dimensional essence embedded in the continuous infinite. And the transfinite is also part of that essence. We can get to a 10th plus dimension. And this is why even the finite people saying, well, we could ultimately calculate the number of atoms in the universe. I'm not even sure at that finite level if you can, because the transfinite effectively can extend forever. You know, they talk about it's the countable infinity. The only trouble is it's not countable. But when you start looking at all of this, you start saying, hold on, there are these connections. They're more than connections. They're unions, that we are dealing with a whole unit of reality. We're not dealing with a single unit and different things. Everything is a unit. Psi is a unit in terms of communications, where you are still using space, time, and consciousness, but just in a different way. And it is a rare phenomenon, because rare events occur which intersect. I was talking about space travel, not only space travel across distance, but across time, potentially, in terms of time travel. You're intersecting certain points, sometimes in a rare event way. And this is part of our whole model of TDVP, triadic dimensional vortical paradigm. You're intersecting all these different areas, and this is suddenly, boom, a psi event occurs. But that psi event might be occurring in dimensional domains 5, 6, 7. It might be occurring much, much higher. And so we've introduced this whole idea, I call it po-life, potential life, before or after physical life. We are still like a butterfly and a chrysalis. We are metamorphosing, but there is no such thing as physical, as death at this ordropic level, at this order level. It is always existing, and we and every kind of thing, even the most fundamental subatomic particle is always existing in union in a different way.
So you're saying that you and I and our viewers and every fly in the room is participating in infinity.
Not only every fly in the room, but every atom, every proton, every electron, even those that beta decay, because there is something else that is replacing. There is no such thing as disorder at that infinite level, and it extends to concepts pertaining to survival. And of course, there is a gigantic amount of data relating to survival after bodily death. And there is, as I pointed out, 9 different areas in Psi research that have statistical chances of less than 1 in a billion against chance. And some of these are interrelated, some of them might not be.
Well, Dr. Vernon Neppe, you're on a roll. Listening to you reminds me of listening to a Mozart symphony. It's very inspirational. Vernon, thank you so much for being with me.
It's my great pleasure.
And thank you for being with us. On June 1st, we just released issue number 2 of the New Thinking Aloud quarterly magazine. You can download a free copy at the New Thinking Aloud Foundation website, newthinkingaloud.org.